Continuing on in Chapter 4, let's talk about precipitation reactions. We have a nice little rhyme here to start the beginning of this section. Solubility rules are really great. They help predict precipitate. What we're talking about here in this section are a certain kind of chemical reaction where when you take two different solutions, so you have a molecule dissolved in water in one solution, you have a different molecule dissolved in water in a different solution, and when you mix the two solutions together, sometimes what will happen is the two molecules that were dissolved in water before will react with each other to form some new molecule that is no longer soluble in water. It will no longer be dissolved in water, and so it will precipitate out of the solution, is what we would call that, the formation of that solid that then drops to the bottom of the beaker. We call it a precipitate. And these types of reactions just in general are called precipitation reactions. So that is the kind of reaction that we're looking at here. Just as an example of when this can happen, you can have a solution of potassium iodide, which is what we have here, Ki, that is soluble in water. It will be dissolved in water. You can have lead nitrate in a different solution. That's what this solution here is. Lead nitrate will dissolve in water. But when you mix the two solutions together, what happens is that all these ions that were dissolved in the solution as separate ions, when they mix together, the lead and the iodide find each other and bond together, and this new molecule that is formed cannot be dissolved in water. Water can't dissolve lead iodide, and so the lead iodide no longer stays as these ions that are floating around in solution. It will then drop out of the solution. So all the molecules we're going to be looking at here, they're always going to be made of ionic compounds. These different solutions, they're always going to be made of ionic compounds. We're not going to have precipitation reactions where covalently bonded compounds are there. You can have covalently bonded compounds precipitating out of a solution, but it's not usually because of these types of reactions. Usually it's because maybe the temperature is changing or something else that's causing that molecule to precipitate out. We are going to be specifically looking at mixtures of ionic compounds that when mixed together make some new compound that is no longer soluble in water. So these we would call insoluble molecules. So things that will not dissolve in water are insoluble. Things that will dissolve in water are soluble. Now, thankfully for us, we do not have to memorize which types of molecules are soluble and which types of molecules are insoluble. You will be able to access this handy little cheat sheet here that tells you what combinations of ions are soluble and what combinations of ions are insoluble. So the way to read this table is everything here on the top, these ions here, are generally soluble. So if you make a molecule, any ionic compound, and it contains one of these ions, it will most likely be soluble, with the only exceptions being what's listed over here. So some of these actually don't have any exceptions. So lithium, sodium, potassium, and ammonium, for example, if there is a molecule with these cations in it, it will dissolve in water, at least somewhat. I will make a distinction here. We're not saying that they are going to infinitely dissolve. There is a limit to how much will dissolve, but you will be able to get some, at least. Some of the molecule will dissolve. So that is always going to be the case for any molecule that contains any of these ions. Same thing with nitrate and acetate. There are no exceptions. Those are always going to be soluble. Chloride, bromide, and iodide are generally soluble, but there are 3 exceptions to that. So if they're bonded to anything else, they will be soluble. But if you have silver mercury or lead bonded to any of these three, then that would be an exception, and it would actually be insoluble. It would not dissolve in water. Sulfate, kind of the same thing, usually soluble, but it has a few extra exceptions here. So we have the silver and the lead, just like before, but now we have barium, strontium, and calcium as other exceptions. That would be insoluble. The bottom section here are ions that are generally insoluble. So these, and there's only 4 of them here, but these 4 ions, if they're in a molecule, the majority of the time that molecule is going to be insoluble. And really the only exceptions here, as you can see, are, well, I shouldn't say the only, but the majority of the exceptions are actually this stuff here from this column, or from this row on the column here. There are a few other ones. So for the sulfide, calcium, strontium, and barium are exceptions. Those would actually be soluble. And then for the hydroxide, it's the same 3, calcium, strontium, and barium. But then these 4 here, these 4 exceptions for each of these, it's just these. Those are the exceptions that it's mentioning. So this table is going to be our guide for figuring out, is this molecule that I could make from mixing these 2 solutions together, is this molecule going to be soluble, or is it going to be insoluble? So let's look at a few examples of some molecules here. So we have some typos here, actually. A should be lead chloride. B should be copper. And actually both of these are 2. Lead 2 chloride, copper 2 chloride. C here is calcium nitrate. And D is barium sulfate. So go ahead and take a look at these 4 molecules, and then using the solubility rules from this table, try to figure out if each of these molecules will be soluble in water or insoluble. So pause the video now and see if you can work that out on your own. Alright, so if you look at the table, what you'll see is that chlorine, or chloride, is generally soluble, but lead is one of the exceptions. So this is insoluble. So you see chloride, generally soluble. Lead is an exception, so it is insoluble. Copper chloride, again, chloride, generally soluble. Copper is not an exception to that. And so this is soluble in water. Calcium nitrate. Calcium, we don't have a rule for. You can see that it's an exception actually to 2 different things. Here it's an exception for being insoluble, and here it's an exception for being soluble. But we don't have a rule for calcium. We do have a rule for nitrate, and that rule is that everything nitrate is soluble. No matter what you attach it to, it is going to at least be somewhat soluble. No exceptions. And then the last one here, barium sulfate. Sulfate is generally soluble. However, barium is an exception to that. And so this is insoluble. Now I do want to make a quick point here that when I write questions for the exams, I'm going to use this table. There is actually a little bit of disagreement as to whether certain molecules are soluble or insoluble. So certain tables, for example, will actually not list barium sulfate as an insoluble compound. Some will list it as being soluble, because in truth it is very slightly soluble, and it really just come down to the judgment of the person that's making that table as to whether or not it is soluble enough to be considered soluble, because this really is on a sliding scale. Certain things are much more soluble than others. And so it is kind of up to each individual scientist. As far as I'm aware, there's not really an agreed upon cutoff to where you say, okay, this is so little of it dissolves that now we consider it insoluble. So there is a little bit of disagreement, but I will be using this table when I write questions for the exams. So if you come across something in the homework that disagrees with this table, I think I've eliminated all of those. When I originally made the homework, there were some of those. There were a couple problems where I didn't realize that the rules that were used for the homework were different than the rules that I was using. I think I've gotten rid of all those, but if you notice one, just let me know. But for the exam, for sure, when I create those myself, I use this table as my key. Alright, a couple other quick things here before we wrap it up for this video. Sometimes, when you take two different solutions and mix them together, you get the most uninteresting result possible, which is nothing. Certain combinations of solutions don't yield any insoluble compounds. So for example, potassium iodide and sodium chloride. There is no combination of these four ions, K+, Cl-, Na+, and I-. There's no combination of these four that gives you an insoluble molecule. And so when you mix those two solutions, well, now you just have the two solutions mixed together. And congratulations. That's all you have now. So when you have situations like this where nothing actually happens, then we just write no reaction. So there's no need to write the possible things that could be formed. Nothing happened, and so we just say that. We say nothing happened, no reaction. All right. I think we'll go ahead and call it there for this video, otherwise it'll be pretty long. In the next one, we will actually talk about writing out the whole equation, figuring out what is, if our reaction is producing something that is insoluble, and then writing that equation correctly, showing all the phases. So we'll do that in the next one.